All right, this is day 1 of the review, of the official review anyways. Problems 1 through 4, it says find f of g of 4 and g of f of 4 of each of the following. Okay, first thing I gotta let you guys know, remember, anytime you see f of g of x or any kind of derivation of that, what it really means is f of g of x written like this. Okay, and I certainly prefer this version because, I don't know, I feel like with the right side you can get a clearer sense of what's on the inside and what's not on the inside, you know what I'm saying? So I prefer this. So the first time I see something like that, when I see something like on the left side, I just convert it to something on the right side. So when I say f of g of negative 4, I see this happening. That's what I want to see, okay? And then I see g of f of negative 4. I don't know. You can do it either way. If you don't do it like that on the midterm, I'm not going to mark you down, but I just think it's more clear when we see these versions of the problem. Anyway, let's take a look at something like number 2. Right? If they ask me to find f of g of negative 4, remember the innermost function is g of negative 4. So my two functions here are f of x equals 3x plus 7, and then g of x equals x squared minus 3. Okay, if I'm being asked to find f of g of 4, or f of g of negative 4, g of negative 4 is the innermost function, so I'm going to take g of negative 4 here, so g of negative 4 equals negative 4 squared minus 3, which is 16 minus 3, so g of negative 4 is going to be, what did I say, 16 minus 3, so 13. Now this 13 here must get plugged back into f. So what you have is f of 13 is what you're trying to find, which is really 3 times 13 plus 7. So that's 39. 39 plus 7 is 46. So f of 13 is equal to 46. And this is your answer. Or you could have written it from the get-go as f of g of negative 4 equals 46. Either one of these answers that's circled or boxed will be correct. Good? Okay, let's do g of f of negative 4 now, backwards. So that means the innermost function is going, if I'm trying to find g of f of negative 4, the innermost function is this f of negative 4. So that's going to be 3. Actually, you know what? Let me split this up here. F of negative 4 is going to be 3 times negative 4 plus 7. So we got a negative 12 plus 7 here. So f of negative 4 is equal to negative 5. From here, I take this value and pump it back into here. So I get g of negative 5 is equal to negative 5 quantity squared minus 3. So that's 25 minus 3, 22. So g of negative 5 is 22. Now that's your answer. Again, or you could have written it the original way. G of f of negative 4 is equal to 22. Either one of those answers would have worked. Okay? I think that's pretty simple. So that's the first section of problems. Next, they're asking us to please evaluate g of f of x and all that composite function mumbo jumbo. Let's do one of each type. Let's see if we can't do, let's see here. Let's do something like number 12. K of x plus h. Well, k of x is equal to x squared minus 2x plus 1. So k of x plus h is going to equal x plus h squared minus 2 times x plus h plus 1. Now we're just going to FOIL this out. This is the left term is x squared plus 2xh plus h squared minus 2x plus 2h plus 1. And that's as far as you need to go for this problem. Okay? Okay, 18 through 21, we actually never really covered, but if you want me to do it, I will do one. Find the next 4 iterations. So, if f of 0 is equal to 3, what that means, if we put it into an xy chart, that means I have a 0 and I put a 3 in there. And then what I do is they say f of n is equal to f of n minus 1 plus 4. Okay, so now if the next term is going to be 1, so it's going to be, you plug in a 1 into here, so 1 minus 1 is 0. I'm sorry, messed up there. F of n minus 1 means the term before. So the term before in this was 3. So 3 plus 4 is 7. All right, and then 2. The next iteration is going to be 7 plus 4, which is 11. And the next one's going to be 11 plus 4, which is 15. And then the next 4 iterations of 4, so it's going to be 15 plus 4, which is 19. Okay. But again, we didn't learn it. It's kind of important to know, you know. Okay, 22. Find the I'm sorry, we don't have to necessarily do 22. Let's do number 24 instead. It says find the inverse of each function. So in order to find the inverse, our original function is y equals 2x minus 5 over 3. First thing we do when we find inverse functions is we flop x and y. So I'm going to change this into x equals 2y minus 5 over 3. And now it just becomes a game of isolating y. So get y by itself. I'm going to multiply both sides by 3. So I get 3x equals 2y minus 5. So then I add 5 to both sides. So I get 3x plus 5 equals 2y. You divide both sides by 2. So you get y equals 3x plus 5 divided by 2. And that's as far as you need to go with this problem. Okay, next one, 26. Or the 26 type of problems. It says 26 to 29, determine whether the following functions are inverses. Now, remember, to determine whether or not things are inverses, we say if f of g of x equals x, and if g of f of x also equals x. Raise your hands if that looks familiar. Like that rule kind of looks familiar. A few people. Okay, cool. So now let's go ahead and look at something like number 29. So my f of x is equal to 3x minus 7. G of x is equal to 1/3 x plus 7. So let's try and figure out what f of g of x is. So that would be 3 parentheses 1/3 x. Looks like x on the outside, so minus 7. Okay, so those are going to go away. I get x minus 7 as my answer. F of g of x. If f of g of x equals x minus 7, are they inverses or automatically not inverses? Automatically not inverses. So the answer here is no. Okay. Okay. We never went over Matthew. What's up, buddy? When they are inverses, then f of g of x has to equal x, and g of f of x has to equal x. Okay, 30 through 37. Go ahead and just cross those off. We didn't have time to go over graphing rational functions. Okay, you guys will see that. Actually, you guys will see a better way of doing it in calculus next year. These are the 3 types of variations that we've dealt with in this class. Who remembers the formula for direct variation? What did that look like? Luke one? Good. What about inverse variation? What did that look like? What about inverse? Anyone remember inverse variation? It was a little more complicated. Carter? Okay. You can do it like that. That's fine. Kind of. Luke one? Carlissa? X sub 1. over y sub 2. Right? Was that it? Okay, cool. Now, Carter, the reason why you threw me off is because I usually have them flipped. And then what was joint variation? Riley. Kxz. And then k is the constant of variation, right? Okay, so why don't we do something like number 41. Okay, it says if x varies jointly as y. If x varies inversely as y, and if x equals 5 when y equals 12, find x when y. Okay, so if it varies inversely, we're going to use the middle formula. So we have to find an x sub 1, a y sub 1, an x sub 2, and a y sub 2. So it says if x varies inversely as y, and x equals 5 when y equals 12, find x when y equals negative 4. Raise your hands if that setup doesn't make any sense to you. Okay. We're going to plug in an inverse variation, so it's going to be x sub 2, so question mark. I don't know why I did that. X sub 2 over y sub 1, which is 12, equals x sub 1, which is 5, over y sub 2, which is negative 4. So now we just cross multiply, or actually just multiply both sides by 12. So you get x sub 2 is equal to that. You got a negative 3, so it should be negative 15. Let's do one more of those. Number 43. If y varies jointly as x and z, and if y equals 42, when x equals 2, 2, when and z equals 3, find x when blah, blah, blah. Okay, so that's all being multiplied by k, right? So we got 42 equals 6k, k equals 7. So now we're trying to find x when y equals 36 and z equals 4. So this is 28, x equals 36. So we divide both sides by 28. I believe they both go into 4, so it's going to be 9 over 7. All right. Those three formulas will appear on your quiz tomorrow as well, the pop quiz. So make sure you guys memorize those. You okay with that, Esther? Good, because even if you weren't, it'd show up anyways. By the way, make sure that you guys have your own calculator for the midterm. Make sure you're not using a cell phone as a calculator. Okay, let's take a look at something like number 48. This is a pretty easy problem. Are you guys okay if I just multiply straight across? If I flip and multiply right off the bat? It was originally a division problem, but I just flipped it, yes? Everyone okay with that? I just skipped a step right there? Okay, good. So now it's got to factor this thing. That's what the top becomes. And then this is x plus 3 times x plus 1 on the left times 3 times x plus 1 over x plus 2. Let's see what's going to get out of here. Looks like the x plus 1s are out. Looks like the x plus 2s are out. So you get 3 times x minus 4 over x plus 3. Okay? Any questions on this problem? All right. Let's see. How about something like number 50? Evil problem. Okay. With this problem, I'm going to take the bottom and parachute it to the top. So I get x to the fourth minus y to the fourth over x to the third plus y to the third times x plus 1. Oh, no, not x plus 1, x plus y. X plus y over x to the third minus y to the third. Okay, the top is going to factor into this. Top left is going to be x plus y times x minus y, but they're both, all four terms are being squared. So you end up getting also an x plus x squared plus y squared times x plus y times x minus y all over. Bottom's going to factor out using little bro, big bro, so that's going to be x plus y times x squared plus xy. Sorry, I'm losing my mind here. Minus xy plus y squared times, you get an x plus y up top here. I'm just messing with the top. And you get an x minus y and then x squared plus xy plus y squared. Okay, what's getting out of here? Looks like those are going to go away. Looks like those are going to go away. Looks like I end up with x squared plus y squared all over x squared minus xy plus y squared times x squared plus xy plus y squared. Okay, so that's how you do those problems right there. All right, let's move on. This will probably be the one of the last exponential or rather rational problems I have to do. Let's do something like 57. Okay, it's a no-brainer. I have to factor it. So 3 over 1 plus x over x plus 2 minus 2 over x minus 2 times x plus 2. Now we need someone to raise their hand and really not think and tell us what is the common denominator between all three of those pieces. Riley. X plus 2, x minus 2. So this one needs an x plus 2, x minus 2. This one needs an x minus 2, and this one needs a 1. So we've got 3 times, let's see here, what number is it? Okay, so 3 times, let's see, x squared minus 4. I just refoiled it back, okay, I just refolded it back to 3 times x plus 4 times x squared minus 2x minus 2 all over x squared minus 4. This thing here at the top comes 3x squared minus 12 plus x squared minus 2x minus 2. So these two are going to combine. They're going to become 4x squared minus 2x minus 14 all over x squared minus 4. Okay, let's do an equation real quick. Let's do something like number 67. 67 is kind of cool because it forces you to do something kind of neat. Esther, what can I do for you since you're out of your seat? Got it. Okay. The first thing you want to do with this problem is factor the left side. So you get 4 over x minus 3 times x plus 1. Now, notice how the middle term is negative x up top, but you have this weird looking x minus 3 type deal. This one here is negative x plus 3, and then when I factor out a negative 1, I get negative 1 times x minus 3. Now then, that's what this whole thing becomes. So I end up canceling the negative x's, so I get x over x minus 3 minus 1 over x plus 1. Each one gets something that's missing. The middle term gets an x plus 1. The right gets an x minus 3. So what you have is, in an equation, what happens to the denominators after you find all common denominators in a rational equation? At least they go away. You get 4 equals x times x plus 1 minus x minus 3. Now, when you subtract x minus 3, is it subtracting the whole thing or is it subtracting just x? The whole thing. So be careful with that. 4 equals x squared plus x minus x plus 3. Those cancel each other out. X squared plus 3 equals 4. X equals what? Plus or minus, whoa, that's an off base, plus or minus 1. Now, you have to check and make sure that your answers work. Do they work? Stephanie, what do you think? Not sure? Carter, what do you think, buddy? -1 does not work, so make sure you show me that you considered it. Remember, Stephanie, if I plug -1 on bottom, what do I get? Right here. What's -1 plus 1? 0. Right? It's 0. So what? Can you have a 0 on the bottom of a fraction? No, you can't. That's why -1 doesn't work. You understand? Okay. All right, let's take a quick break from that. Go ahead and work on your own for a little bit, and then I'll compile this, and then we'll get going again, okay?